Hey, what up everybody? Coming at you with a quick video about momentum and kinetic energy. To help introduce these important topics, we have our friends Mo and Ken, and they're going to explain momentum and kinetic energy. Hopefully they won't fight this time. Velocity is boring. A ping pong ball and a bowling ball roll down a hallway. Are they the same? No, there's more than velocity. Let's study momentum. Momentum is how hard it is to stop something. Momentum is equal to mass times velocity, or P equals mv for short. Something has momentum if it has mass and it is moving. So while all moving things have momentum, some have more than others, and the things with more momentum are harder to stop. The more mass an object has, the more momentum, and the more velocity it has, the more momentum. But mass and velocity are equally important. If you double the mass, you double the momentum. If you double the velocity, you also double the momentum. What is the momentum of a blackbird with a mass of 0.4 kilograms, flying at 19 meters per second? Look how easy this is. You just multiply the two numbers together, the mass and the velocity, and you get the momentum. This blackbird has momentum of 7.6. With this, we can tell how hard it would be to stop the blackbird. Too simple. Let me introduce you to kinetic energy. Kinetic energy is how much energy it takes to get something moving at a certain speed. Kinetic energy is equal to 1/2 mass times velocity squared. 1/2 mv squared. Check out these animals. I'll rank the animals by kinetic energy. You can talk about their momentum. I don't like the elephant. It's big, but it has no velocity. No velocity means no momentum. See, 1,000 times 0 is 0. I don't like the elephant either. No velocity means no kinetic energy. 1/2 of 1,000 times 0 is just 0. Now let's talk about the lion. It has a mass of 50 kilograms and a velocity of 1. Can you figure out the momentum of the lion? Start with the equation P equals mv. Very good. 50 times 1 is 50. The lion has a momentum of 50. Now find the lion's kinetic energy. Use this equation, 1/2 mv squared. Very good. Putting the numbers in, we found that the kinetic energy of the lion is 25 joules. Finally, the falcon has a mass of 1 kilogram and a velocity of 50 meters per second. Can you find the falcon's momentum? Start with P equals mv. Correct. The falcon has a momentum of 50. The falcon is just as good as a lion. They both have a momentum of 50. Not so fast. Let's find the falcon's kinetic energy. Start with 1/2 mv squared. Exactly. Because the falcon has such a fast velocity, and that velocity gets squared, you get a rather big number. It has a kinetic energy of 1,250 joules. It would take a lot of energy to get the falcon moving at the speed at which it's moving. Wow! The falcon is much better than the lion. Look how much kinetic energy it has. See, mass is important, but velocity is more important. No, the falcon is not better. The lion is just as good. They have the exact same momentum. Too simple now. The falcon is much better. Look how much kinetic energy it has. They are the same. Okay then. You take the lion. I'll take the falcon. Fine, but my lion is just as good as your falcon. You think too much. It takes more energy to get the falcon moving 50 meters per second than it takes your lion to limp around at 1 meter per second. Well, maybe they should fight. You savage. Thank you, Mo and Ken. So just to review, momentum measures how hard it is to stop an object. It is found by multiplying the mass and the velocity. The mass and the velocity are just as important. If you double one, you double the momentum. Kinetic energy, on the other hand, places more importance on velocity. The velocity is squared in this equation. So if you double the mass, you'll double the kinetic energy. But if you double the velocity, you'll quadruple, or 4 times, the kinetic energy. Kinetic energy measures how much energy it takes to get the object moving at the speed that it's moving at. Both are important. Hope you enjoyed this video. Join us again to hear Mo and Ken explain more about momentum and kinetic energy.